Namaste everyone, welcome to my class. I am Vinod. We are in 9th standard, chapter 10, second part of the gravitation lesson, thrust. And so in the previous class we have learned about the pressure inside the fluids. So liquid pressure we have calculated. So in this class I would like to discuss on upthrust or buoyant force. So upthrust is nothing but whenever we try to immerse any object into the fluid, so we experience an upward force acting from inside. So take the small example where I have drawn one plastic bottle for which the cap is fixed, and when you try to insert it into the water, it's an empty bottle, so you will find that it will not go very much easily inside the water. Instead, what happens now, it experiences an upward force from within the water. One more important thing what you notice here is, as you push the bottle inside, so that is when the volume of the bottle which goes inside the water increases. So if you are pushing it a little more inside, so you can experience or you feel like there is more upthrust. So upthrust depends on the volume of the body immersed inside the fluid. 2 points once again I will repeat. So upthrust is nothing but whenever you try to immerse any object into a fluid, it experiences an upward force, and that upward force depends on the volume of the immersed part of the body. If the volume of the immersed part of the body, that is, if it increases, definitely the upthrust goes on increasing. So we will try to find out what exactly is the reason for upthrust. Okay, to find out the reason for upthrust acting on an object when it is immersed in a fluid, right now I have taken a small cube, a shape of a cube which is immersed in a fluid. Now in the last class we have learned about pressure in fluids. So I am taking two surfaces, the top surface and the bottom surface. The top surface is at level A, what I have written is at less depth from the surface of the fluid, and the bottom surface is at level B at more depth, which is at higher depth, greater depth from the surface of the liquid. So the reason for the upthrust is because of the weight of the water on the top of the surface A, there will be downward pressure or force acting in the downward direction, and then this is at lower level. So as we have learned that in liquids pressure increases with the depth, and it is in all the directions, it is not in one particular direction. So here on the surface A, surface B, at this level B, the bottom surface, pressure will be experienced from downward direction. So from the concept of difference in the pressures, we can understand that the pressure at lower depths, at lower heights or at depths is greater than the pressure near the surfaces. So here you can see that the pressure which is acting from down is more responsible for the upward force, or one of the reason why an object when it is placed inside the liquid will experience an upthrust. So we have even the pressure acting on the walls of the object which is immersed in, but this equal and opposite, since these forces are equal and opposite, they are no way in response, or they are no way in contributing to the upthrust. Only the forces or the pressures differences between the upper surface and bottom surface are responsible for upthrust. Based on this concept, we will derive an expression for upthrust on an object when it is immersed in a liquid. Okay, we will try to derive an expression for upthrust acting on an object. So right now, this is a beaker in which fluid is taken. In this beaker, a cylindrical object is inserted. The height of the cylindrical object is h. The cross-sectional area of the cylindrical object is A. This cross-sectional area is A, small a. Then I have the two surfaces at different depths from the surface of the liquid, the two surfaces of the cylindrical object. So the top surface is at level A, which is at depth h1 from the surface of the liquid, and the bottom surface is at level B, which is at a height h2 from the surface of the liquid. So here I have written height of the cylinder, cross-sectional area A, volume of the cylinder is V, and the density of the fluid in which it is placed is rho. So since we have found out like the upthrust is due to the difference in the pressures, first we will calculate the pressure at both the points, at level A and at level B. So pressure at level A, so that is the pressure acting on the top surface. So we have an expression for pressure acting, it is H, rho is the density of the liquid, H rho G. This H is nothing but height or the depth. So here at level A, it is at depth H1 rho G. Now pressure acting on the second surface, which is at level B, that is very much responsible for the upthrust, pressure at level B. So that is at the depth H2, that is at depth H2 from the surface of the liquid. So H2 rho G, density of the liquid into acceleration due to gravity. Then so we will, the reason for the upward thrust is, so since the pressure at the level B is greater, so the resultant pressure acting on it in upward direction is, so total pressure acting on the cylindrical object is P equal to pressure at this level B minus this is, which is a heavier one, or more pressure, minus the downward pressure exerted by the liquid column. So pressure at level B minus pressure at level A. So which is equal to, P is equal to H2 rho G minus H1 rho G. So H rho G is common in both the cases. So I am going to take H2 minus H1 rho G. Density of the liquid and acceleration due to gravity is common. So right now we will come to this once again. So this is our H2 and this is H1. So if you subtract H2 minus this height minus H1, the resultant will be exactly the height of the cylinder. So in place of H2 minus H1, I can substitute it as H. So I am going to write it as pressure equal to H rho G. That is the resultant pressure, H rho G. So now we have to calculate the upthrust. So how is pressure related to the upthrust or thrust? So we know that according to the formula, pressure is equal to force by area. So pressure equal to thrust by area or force by area. Right now I am going to put small a because we have taken the cross sectional area small a. So I want now the upthrust. So it is equal to force. In this case I am going to write it as upthrust. The upward force which we are going to calculate is equal to the pressure exerted, the resultant pressure and the cross sectional area. So which is equal to F upthrust is equal to, so P is H rho G, and I am going to take the A in the front, AH rho G. Now once again, density, rho is density, don't get confused. A into H, AH. So when you multiply the cross sectional area, pi r square and H, A is pi r square H, which is equal to the volume of the cylinder. So we are going to write this one as V rho G. V, density of the liquid, and the acceleration due to gravity, upthrust. So this is very important equation. Upthrust exerted by a liquid depends on volume of the body which is immersed in it, density of the liquid, and acceleration due to gravity. Since this is density of the liquid, don't get confused, it is equal to the volume of the object immersed in the liquid. So volume into density, one more equation we are going to write that is very much close to the Archimedes principle. So volume into density, we have learned density is equal to mass by volume. So here volume into density will give you mass. In place of volume into density, you substitute mass. So F upthrust is equal to mg. This m is nothing but densities of the liquid and volume is of the liquid displaced. So it is mass of the liquid into acceleration due to gravity. So which is exactly equal to the weight of the liquid displaced. Weight of the liquid displaced by the immersed portion of the body. So this is an important second equation. The first equation tells us upthrust depends on the volume of the immersed part of the body, density of the fluid. The more the denser the fluid is, or the more the density of the fluid is, the greater will be the upthrust, and acceleration due to gravity. Then the second one is upthrust is nothing but it is equal to the weight of the water displaced by the immersed part of the body. One more thing, upthrust is inversely proportional to the temperature. If we are taking them as directly proportional to the volume, to the density of the liquid and acceleration due to gravity, so upthrust is inversely proportional to the temperature. If the temperature of the liquid increases, upthrust or the buoyant force decreases, because the volume increases as a result. On heating, volume increases as a result. The density of the liquid decreases. Okay. Thank you everyone. We will meet in the next class on a discussion on Archimedes principle and the principle of flotation.